Okay, please have your calculator with you because today we want to do some practice questions. So you will need to let me know the answers to the calculations that we're doing. Okay, everyone, let's begin then. So we were doing differential equations. We are done with most of the concepts of this topic already. We've talked about how to solve differential equations by separating variables, right? That's what we talked about. We did some examples on that. This is the process to solve differential equations. You separate the variables, integrate both sides, one with respect to y, the other with respect to y, but the other with respect to x. And then you input the given values of the variables to find c. You have a plus c on one side, you find the value of c using the given values. And then you just convert the equation to the form that's required. It might ask you to make x the subject or y the subject or something else the subject, whatever they're asking for, you make that variable the subject. Then in the last class, we talked about forming differential equations. Sometimes you have to make a differential equation yourself using the given information in the question. So it'll be like word problems. You need to understand how to convert each of these different statements to a mathematical form. For example, if it says rate of change of y is directly proportional to x squared, you could write something like this. If it says rate of decrease of y is inversely proportional to x plus 3, how do you write that? Dy by dt that equals minus k, minus because of the decrease, and then k over x plus 3. This is how you would use that. And then we talked about what happens if you have something increasing and decreasing at the same time. So we talked about this example where we had water pouring into a container. We had rate of inflow and we had rate of outflow. The overall rate of change, dV over dt, we said that would be rate of inflow minus the rate of outflow, right? We did some examples in this as well on how to form differential equation. There was another thing that we also learned there, that sometimes you have information given in the question about one variable, and the differential equation that you're supposed to prove or show is in terms of another variable. You also need to use chain rule and examples like that. So we did this question in particular, question number 2 from the worksheet, where the given information was in terms of volume, and what we had to prove was in terms of h, which was the depth of water. So in order to go from dV over dt, once we wrote this equation, when we had to go to the other equation, we needed to use chain rule here. So sometimes while proving differential equations, you also need to use chain rule. You need to keep that in mind as well. All right, so these are all the concepts that we've done until now: how to solve differential equations and how to form differential equations. Now, I told you there's one type of question that we have not talked about, and that is the last part of some of these differential equation questions, in which they ask you about what happens to a certain variable if another variable becomes very large or very small. Let's look at one such example here. So today we want to do some practice questions, and while we do those practice questions, we in particular want to practice these last parts of these questions that talk about something like that, that what happens to a variable if another variable becomes very large or very small. Let me have a look at one such example. Yeah, so let's start with this one. This is question number 13 from the worksheet, question number 1313. Let's start with this. So using this question, we want to understand what happens in questions like these. State what happens to the value of x when t becomes very large. Explain why x increases as t increases. So we will learn how to approach these problems, okay? And then we'll do more practice questions from differential equation worksheet as well. You can let me know in the chat box the problems that you have. You can write down your problems there so that we can discuss those questions as well after this one. Okay, so what does it say? We have this differential equation in part 1. E raised to power 2t into dx over dt, that equals cos square x. And we are given that t is greater than or equal to 0. And then it says when t equals 0, x equals 0. This is a point that we're given that we can use to find the value of c. Now, in the first part, they ask us to solve this differential equation, obtaining an expression for x in terms of t. Now, how do you do that? How do you start with this? The first thing you have to do is you have to separate the variables. You want x terms on one side and t terms on the other side. So how do we do that? We first take dt to the other side, so that it becomes e raised to power 2t into dx. And on the other side, you have cos square x into dt. Now, whichever side has dx, we want x terms on that side. And whichever side has dt, we want t terms on that side. So cos square x will need to come to the left, and e power 2t will need to go to the right. Right? That's what needs to happen. So how do you do that? You say this is 1 over cos square of x into dx. Take e raised to power 2t on the right side, it becomes 1 over e raised to power 2t dt. You have separated the variables. X terms are on the left side now, t terms are on the right side. Okay? How do you integrate both sides now? So once you've separated the variables, the next thing that you have to do is you have to integrate both sides. You integrate the left-hand side and you integrate the right-hand side. What is the integral of 1 over cos square x? How do you integrate 1 over cos square x?
So we can write it as the secant square x.
We can write this as secant square x, right? We have done this before. We can't use any fraction rules here. 1 over cos square is basically the same as secant square x. And we know the integration of secant square is tan x, so it becomes tan x. Now, what about the other side? How do you integrate 1 over e raised to power 2t? What about this?
We can write it e raised to power minus 2t and use the exponential.
We take this to the numerator and write it as e raised to power minus 2t. And now we just integrate it like we integrate any exponential function. E raised to power negative 2t, what's the integration of that? E power something remains e power that thing. When you integrate, so it remains e raised to power minus 2t. But then you have to divide by the derivative of this thing. What's the derivative of minus 2t? It's minus 2, so you divide by minus 2, and you have plus c with that. All right, so you put plus c on any one of the two sides, it doesn't matter. We are putting plus c on the right side here, okay? That's equation solved. That's the differential equation solved. Now, the next thing we have to do is we have to find the value of c somehow. How do you find the value of c? You've got this point given. It says t equals 0, x equals 0. When t equals 0, x equals 0. We can use that to find the value of c now. Let's simplify this first. It becomes tan x equals minus 1 over 2e raised to the power 2t. So I'm just making this power positive. I could write it in the denominator, or you can leave it in the numerator as well. That's perfectly okay. But that's what you can write it as. Now you input those values. You say for t equals 0 and x equals 0. That's a point that we're given. You can use that point to find the value of c and see what that gives you. So tan of 0, that equals minus 1 over 2e raised to the power 0 plus c. Tan 0 is 0. E raised to the power 0 is 1. So it becomes minus 1 over 2 plus c on the right side. The value of c turns out to be 1 over 2. And now, what does this equation become? It becomes tan x equals minus 1 over 2 e raised to the power 2t plus 1 over 2. And we have found the value of c now as well. All right. Now they wanted us to obtain an expression for x in terms of t. So x needed to be the subject here. X needed to be the subject here. How do you make x the subject? You can take tan to the other side, and that becomes tan inverse of minus 1 over 2 e raised to the power 2t plus 1 over 2. Or you can write it as 1 over 2 minus 1 over 2 e raised to the power 2t. That is x in terms of t. And that's what we were looking for. That's the first part of this question. Okay? X in terms of t, we have found that. Okay? That was 6 marks. And now let's look at the second and third parts. You often have parts like this after you're done with solving the differential equation, where they ask you to state a value of a variable given something that happens to another variable. So in this case, they say, state what happens to the value of x as t becomes very large. Now, what does that mean? T becomes very large. That basically means that t goes towards infinity. T becoming very large, that means t goes towards infinity. So what happens to x as t goes towards infinity? That's what you have to write down. Now, what happens does not mean that you have to write down in words that, okay, x is going to become small or large. You have to write down a value for x, right? They expect you to state the value of x that you're going to get when t becomes very large. Now, how do you think about that? You have x in terms of t here. You've got x equals tan inverse of 1 over 2 minus 1 over 2 e raised to the power 2t. What happens if t becomes very large? Now think about this. In this whole expression, the variable is only t, and that is in this position, 2e raised to the power 2t. Now let's think about this. As t becomes very large, as t goes towards infinity, what do you think is going to happen to 2e raised to the power 2t? What's going to happen to this? 2e raised to the power 2t?
It's going to increase.
This is also going to go towards infinity, right? You have e raised to the power infinity. E is a positive number raised to power an extremely large thing. This is also going to go towards infinity. Okay. So that means this denominator is now extremely large. Now, if the denominator is extremely large, what happens to 1 over 2 e raised to the power 2t? What happens to this? 1 over an extremely large number. What is this going to be?
0.
This is going to go towards 0. So when the denominator becomes very large, this whole fraction approaches 0. Now, if this whole fraction approaches 0, this is 0 now. What are we left with? We're just left with x equal to tan inverse of 1 over 2 minus 0. Or you can say x equals tan inverse of 1 over 2. This is the value that x approaches as t becomes very large. This is one way to think about this. This is one way to think about this. You could say, you could basically think of it like this: as t becomes large, what happens to the value of x like this? Now, this is one possibility. Another way to think about this could be, so if you find this difficult, if you find difficult to logically think of it like this, that, okay, if t becomes large, what happens to this expression? Another possibility could be that you just input this thing in your calculator. Now, let me show you how that's going to work. So you have x equals tan inverse of 1 over 2 minus 1 over 2 e raised to the power 2t. Put this function in your calculator, and instead of t, write a large value. Instead of t, write down a large value. Okay. So basically, you could write something like this in your calculator: tan inverse of 1 over 2 minus 1 over 2 e raised to the power 2 multiplied by t. Instead of t, write something large. So generally, I put something like this: 10 raised to power 10. Okay. But sometimes what happens is this number is going to become so large that your calculator is going to give you an error, because the calculator will not be able to evaluate it sometimes. In this case, most likely that is going to happen because it's in power here. So this number e raised to power 10 raised to power 10 is extremely large. Let's make it slightly smaller. Try this on your calculator if it works. So if you have 9,999, something like this, so an extremely large number like this, what do you get? Is your calculator giving a result, or is it an error still?
So it's still an error.
It's okay. It's an error. That means this number is still very large, and the calculator is unable to evaluate it for that reason. Make it slightly smaller, 999, for instance.
Still doesn't work.
Doesn't work? Which calculator do you have?
Sir, FX 991.
Okay. I think that can handle such large values. You can try 99 then and see what happens in that case.
It's giving 0.463.
Okay, so it's giving 0.463. Now, when you get a value, you can try another value very close to this. Try 100, for instance. If it's giving you the same result, that means that's it, 0.463. You can evaluate this as well, and you can see this will also give you the same result. This is also going to be 0.463. So this could be another way to thinking about this, that in your calculator, instead of t, just put a large number, a large value like this. Does that make sense?
Yes.
Okay. So that's the second part of this question. Now let's look at the last part, part 3. So I'll give you a minute to think about this. I just need a break for a minute. I need to talk to someone. Think about this and let me know how we can do this last part. Now explain why x increases as t increases. What does the statement mean? How can you figure this out now? Part 3. Okay, I'm sorry about that. Okay, so how do we do this third part now? It says, explain why x increases as t increases. How do you think about this now? Let's look at what we have found here, x in terms of t. As t increases, how can we say that x increases? It's tan inverse function You don't really know much about this function. You know about tan, but not about tan inverse, right? So it's going to be hard to think of how x increases as t increases looking at this function. How else can you think about it? So tan inverse function, you don't even know how the graph of this looks like. Otherwise, you could maybe argue that the graph looks like this. It's upward sloping. So that's why as t increases, x increases. But you don't know about the graph of tan inverse function, right? How else do we think about this? How do you understand the statement? It says x increases as t increases. That means they're both moving in the same direction. Now, as x increases and t increases, that means they are directly proportional to each other in a way, right? They're directly proportional. If they're directly proportional, their graph is going to be upward sloping like this. Now, it could be like this, it could be like this. We don't know what exactly the shape looks like. But whatever it looks like, it's going to be upward sloping. So this statement, what we can understand from this is that the gradient is supposed to be positive. Gradient of x and t, when they are drawn on a graph, their gradient is supposed to be positive. Now, how do you find gradients of curves? Using differentiation. Can you somehow find dx over dt, derivative of x with respect to t? Well, you have tan inverse of something here. You could try that, but there's no need of doing that because you already have this differential equation. You can just make dx over dt the subject here. What does that give you? If you make dx over dt the subject, that gives you dx over dt equal to cos square x over e raised to power 2t. That is what dx over dt is. So if gradient is positive, we need to basically show somehow or explain that dx over dt, that is positive. Now, how do you show that? How do you explain that? Let's think about this. So part 3, we know that dx over dt, that is cos square x divided by e raised to power 2t. That is dx over dt. If we can somehow prove that this is positive, then that would mean that as x increases, t increases, right? Because then the gradient is going to be positive. Now, how do you prove that this is positive? In the numerator, you can see you have a square, cos square x, right? A square is always positive, or the least it could be 0, right? It can't be a negative value. So numerator is greater than or equal to 0. Because it's a square, it cannot be negative. What about the denominator? E raised to power 2t. E is a positive number. A positive number raised to power anything is always positive, right? Even if the power was negative. In this case, in fact, power cannot even be negative because it says t is greater than or equal to 0. The power cannot even be negative here. So what that means is the numerator here, the denominator here, this is always going to be positive as well. So numerator is greater than or equal to 0. Denominator is greater than 0. Therefore, we can say dx over dt, that is supposed to be greater than or equal to 0. That means this is kind of positive. So as x increases, t increases. That is what we understand from this. And in fact, in this case, you could also argue that cos square can't be equal to 0 as well, because if it was equal to 0, When would this be equal to 0? When is cos equal to 0? Cos is 0 at pi over 2, right? At pi over 2, if it was if this was 0, how would the left side be 0? If the gradient is 0, okay, I'm sorry. 0 is possible. 0 is possible, but it can't be greater than 0. I was just thinking that since this cannot be 0, so we could say this is always greater than 0. So that means that this is also greater than 0, but that's not necessarily true because the gradient could be 0. That could make cos square 0. So yeah, so that's not necessary. But so what do we understand from this is numerator is greater than equal to 0. Denominator is greater than 0. That means overall, the fraction that is also going to be greater than equal to 0. That means as x increases, t also increases. It cannot decrease. And that is what we wanted to prove here. Does that make sense? Any problem with this?
So how did we connect the derivative with the questions?
It says as x increases as t increases. X increases as t increases. What does that tell you about the graph of this function? So let's say you have t here and you have x here. X is supposed to increase as t increases. So basically, as we go to the right, the graph should go up. So it could either look like this, or maybe this, or maybe this. It can't be a straight line. So it's either a shape like this or a shape like this. In both of them, you can see the gradient is positive. Since the gradient is positive, how do you find gradients of curves? dx over dt. So we say dx over dt has to be positive. Does that make sense?
Yes, sir.
So this statement basically means that gradient is supposed to be positive. And gradient for curves is dx, is basically the derivative. In this case, the variables are x and t. So we say dx over dt has to be positive. Okay. Any other questions on this?
Sir, I have a question.
Yes.
Sir, how did we wrote cos square x is greater than or equal to 0 and e raised to power 2t is greater than 0?
Cos square x means cos of x whole squared. A square can never be negative, right? The result from a square can never be negative because square makes everything positive. So the least it could be 0. In the denominator, we have e raised to power 2t. E is a positive number. E is basically 2.718 and so on. It's an irrational number, 2.718 raised to power something. Now, a positive number raised to power anything, it can never be negative. It cannot even be 0, right? Even if you have a negative power. So if you had, for instance, 2.718 raised to power minus 2, it would just be 1 over 2.718 raised to power 2. And that's still a positive number. So that's why the denominator is also always positive. Okay. Now, in this case, I expect you to understand this logic. And the examiner would expect you to understand this logic as well. But you're only going to get marks for writing this one statement. You just have to write dx over dt is greater than equal to 0. If you've written that statement, that is what is going to get you marks for this. All right. Now, even if you do not explain this reasoning in a lot of detail, it's just a 1 mark question. And that 1 mark is basically for writing this, that the derivative is greater than equal to 0. Since the derivative is greater than equal to 0, that means that as t increases, x increases. Right? So that's what the examiner is basically looking for here. Any problem with this? Any questions? No? Okay. So now you understand how to approach this last part of such problems as well. Let's have a look at another question now. So if you have any problems from the worksheet, you can let me know. We could discuss them. Otherwise, I'll just choose some myself and we could have a look at those questions to do some more practice. Does anyone have any particular question on differential equations? Or you haven't attempted many questions yet? Okay, please make sure that you do this practice. It's really important. So if you haven't done many yourself, let me just do a couple myself then. Okay, let's start with this one. This is question number 15 from the worksheet. You can also have a look at the worksheet and see if there are any questions that you do not understand. Let me know about them. We could try some of them. This is question number 15. Let's start with this one. Okay, so it says a certain substance is formed in a chemical reaction. The mass of substance formed t seconds after the start of the reaction is x grams. Okay, so the substance is being formed. You have time as one variable, t seconds. Mass is the other variable that's measured in grams and it's denoted by the letter x. These are two variables that you have, x and t. It says at any time, the rate of formation. So when they talk about rate, that statement is basically going to tell you how you're going to form the equation. So it says rate of formation of the substance is proportional to 20 minus x. Now proportional means it's directly proportional. Rate of formation of the substance is directly proportional to 20 minus x. Now when t equals 0, x equals 0, and dx over dt equals 1. That's what we're given. It says, show that x and t satisfy this differential equation. So in the first part, you basically have to show this differential equation. Now, how do you do that? It says rate of formation of the substance, rate at which the substance is forming. How is the substance measured in grams? And what's the variable that we have for that for mass? It's x. We can say dx over dt. That will be the rate at which the mass of the substance is changing. Right? When it's forming, the mass of the substance is going to increase. So rate of formation of the substance is proportional to 20 minus x. So we say dx over dt that equals k into 20 minus x. That is what the differential equation is going to be like. Okay. Now we're given a point when t equals 0, x equals 0, dx over dt equals 1. We can just input those values here to find the value of k. So we have x equal to 0 and dx over dt equal to 1. We could just input those two things here. And that gives us 1 equals k into 20 minus 0. The value of k turns out to be 1 over 20. They've written this in decimals. So 1 over 20 in decimals, that is 0.05. So that's the value of k that we've got. And now we can say the differential equation looks like this. It's dx over dt equal to 0.05 multiplied by 20 minus x. That is what the differential equation looks like. That's what we had to prove in the first part. Okay. Now it says, find in any form the solution to this differential equation. Now, in any form means you do not need to have a particular variable as the subject. It could be in any form. Okay. So you need to get rid of dx over dt from this equation and write an equation that connects x and t. Okay, now let's see how we can do this. So dx over dt equals this thing. Now, part 2, we have this equation. First of all, we need to separate these variables. We only have x in the equation. We have to bring x to the left side. So it becomes 1 over 20 minus x into dx. We can bring dt to the other side, and that gives us 0.05 into dt. We have separated the variables. Okay. Now this 0.05 is a constant. You could bring it to the left side if you wanted. You could leave it here on the right side. It would not make any difference. But we have to bring 20 minus x, that whole thing, to the left side. Okay, so this is what we get. Now the left side only has x, the right side only has t. We integrate both sides now. Integrate the left hand side with respect to x and integrate the right hand side with respect to t. What's the integration of 1 over 20 minus x? Which rule can we use here?
ln rule.
ln rule. What's the derivative of the denominator? Derivative of 20 minus x is minus 1. We want minus 1 in the numerator. For that, what we can do is we can put a minus sign inside and a minus sign outside. And now it can be integrated to ln of 20 minus x. The negative sign outside will remain as it is. What about the right hand side? 0.05. What's the integration of 0.05 with respect to t? This is going to become 0.05 multiplied by t, and then you have a constant. This is the solution to that differential equation. But now you need to find the value of c. How do you do that? You have this point given again. T equals 0, x equals 0. Just put those two values here. You put t equal to 0 and x equal to 0. And see what that gives you. Minus ln of 20 minus 0, that equals 0.05 into 0 plus c. Now c equals minus ln of 20. So what does that equation become now? ln minus ln of 20 minus x equals 0.05 into t minus ln of 20. And that's your solution. Now, they did not specify what variable should be the subject there. So we don't necessarily have to make any of them the subject. However, since we have multiple log terms, remember, whenever we have multiple log terms, it's necessary to convert them to a single log term. That is going to be important. You have to convert it to a single log term. Okay, that's necessary. Now, how do you do that? How do you convert it to a single log term? You can take this to the other side, for instance, or maybe bring this ln term to the left side, and that will give you something like this. ln of 20 minus ln of 20 minus x. On the other side, you've got 0.05 times t. Okay, you have to convert it to a single ln. So now we have subtraction outside log. Inside the log, it's going to become division. So it becomes ln of 20 over 20 minus x. That equals 0.05 times t. And that is your solution to this differential equation. You could leave it like this now because they haven't really specified if you want to make a particular variable the subject. This is still important to convert it to a single log term. We have done that. And you can now just leave it like this. Okay, and that will be your final result. Okay, now let's look at the next part. Let's look at the third part of this question. It says, find x when t equals 10, giving your answer correct to one decimal place. So now you need to find the value of x when t equals 10. That's the third part. Now, how do you do that? You can just input that value of t here. Part 3, you put t equal to 10. What does that give you? ln of 20 over 20 minus x equals 0.05 multiplied by 10. And that becomes ln of 20 over 20 minus x equals 0.5. You want to find the value of x now. How do you do that? Again, you need to use log concepts here. What's the base of ln? The base of ln is e. E will go to the other side, become the base of 0.5. So we could write this like this. We could say this is 20 over 20 minus x equal to e raised to the power 0.5. Remember, we want to find the value of x. So we want to get rid of that ln so we can make x the subject. So this is what we do. Now we just take this term to the right side, bring e raised to the power 0.5 on the left. So it becomes 20 over e raised to the power 0.5. That equals 20 minus x. And then x equals 20 minus 20 divided by e raised to the power 0.5. If you wanted an exact answer, you could just leave it like this. But in this question, in this part, they ask us to write down the value of x correct to 1 decimal place. What's this value from your calculator?
7.9.
7.9 correct to 1 decimal place. Okay, that's the third part. That's what we had to do here. Okay. Now in the next part, it says, state what happens to the value of x as t becomes very large. So again, it's that type of problem in which one variable becomes very large. If it becomes very large, what does that mean? It goes towards infinity. So what happens to x? What value of x do you get when t becomes large? Now for this, you need to make x the subject. You've actually done most of this work already in the previous part. But in the previous part, you put t equal to 10, right? So if t was not 10, you would get something like this again. X in terms of t. However, instead of having 0.5 as the power, what should you have? You had 0.05 t here, remember? So this could be written as 20 over 20 minus x equals e raised to the power 0.05 t. And then when you rearrange everything, instead of e power 0.5, you would have 0.05 times t, right? This is what it would look like when you have x in terms of t. All right? X in terms of t would look like this. And now what you need to do is, you need to state what happens to the value of x as t becomes very large. Again, you could think of it logically like we did before. That, okay, think about what happens to e raised to the power 0.05 t when t becomes large. So let's think of it logically first. One possibility could be you think of it like this. As t goes to infinity, what happens to e raised to the power 0.05 t? It's going to become e power infinity. That's also going to go towards infinity. Then what happens to 20 over e raised to the power 0.05 t? 20 over an extremely large number, that is going to approach 0. So that means this whole thing, this is going to approach 0 when t becomes very large. Now, if this approaches 0, what's the value of x that you're going to get? 20. So you say x is supposed to be 20 minus 0, and that's just 20. This is the value of x that you get when t becomes very large. Okay? This is one way to think about this. You could do it the other way as well that we discussed, and that was just input a large value of t here in your calculator, and your calculator will give you a result. So e raised to the power 0.05, again, for the large numbers, something like this. Try this. If it doesn't work, make this number slightly smaller. Does this work? 9,999? Do you get a result for this?
No, sir.
No, sir.
No? Okay, so try 999 then. If that's giving you an error, try this.
20. It's
Oh,
even.
20.
So this gives you 20, and that's what we were looking for. So just input a large value, Now, if you put a very large value, sometimes your calculator is giving you an error, going to give you an error for that, because the calculator will not be able to evaluate that result because of how large it is. In that case, make it slightly smaller than what you initially input and eventually get a result. And that's what you're looking for, x equals 20. This could be another way of thinking about this. So one way to think about this is logically like this. The other way is just inputting values in your calculator, inputting a large value in your calculator. Make sense? Any problems? No? Okay, so you can let me know if there are any other questions from the worksheet. I'll do one more, otherwise then we could end. Do you guys have any problems? Any other question from the worksheet or from any recent papers? Okay, let's do this once then. So question number 27, Amna is asking about this. Let's try this. Okay, question number 27 from the worksheet. Now this looks like a relatively complicated one. Let's try this. Okay, question number 27 from the worksheet. Liquid is flowing into a small tank which has a leak. Initially, the tank is empty. So now this statement is important. Initially, the tank is empty. What does that mean? It means when time equals 0, the volume of liquid in the tank, that is equal to 0 because it's empty, right? And then what happens is t minutes later, so that's the variable that you've got, t minutes later, the volume of liquid in the tank is V centimeter cube. So one variable is t, that represents time in minutes, and another variable is V, which represents volume. The liquid is flowing into the tank at a constant rate. So now that's the statement that's basically telling you how to form the differential equation. That's telling you the rate of something. Liquid is flowing into the tank at a constant rate of 80 centimeter cube per minute. So that's the rate at which liquid is flowing into the container. But because of the leak, the liquid is being lost from the tank at a rate which is at any instant equal to K times B, where K is a positive constant. Write down a differential equation describing the situation and solve it to show that V equals this thing. Okay. Now, mostly when they ask you to write down a differential equation, they give you the final result for that what the differential equation looks like. But in this case, they haven't told you what the differential equation is. They've told you what the final result is going to be at the end. So this is kind of more tricky because you will only find out if the differential equation you've written is correct or not once you get to the final result. So that's kind of slightly more complicated because you need to make sure that you write down the differential equation correctly. Now, you don't have a backup there. You don't have the actual result given there. So liquid is flowing into the container at a rate. How is liquid measured? In volume, dV over dt. What's the rate of change of volume? It's flowing into the tank at a rate of 80. So we say that's 80. That's the rate of inflow. And then it's being lost at a rate that is equal to kV. So we just say minus K times V. That is what the differential equation looks like. Okay. And now you need to solve this differential equation. The problem is we do not have any value for dv over dt at any particular point that we can use to find the value of k at this point, right? It doesn't tell us the rate of change of volume at any particular point, so we can't find the value of k yet. In fact, if we look at the final result that you want, the answer at the end is supposed to be in terms of k. So you can't find the value of k. This will remain as it is. So now let's start solving this differential equation. How do you solve differential equations? You have to separate the variables. How do you separate the variables? You can bring dt to the right side, and that's going to give you dv equal to at minus kv whole multiplied by dt. Now t terms have to be on the right, v terms have to be on the left. There's no t term. You just take this whole thing to the left, so it becomes 1 over at minus k times v into dv, that equals dt. And now you integrate both sides. Now that you've separated the variables, you can integrate both sides. You integrate the left-hand side and the right-hand side. On the right-hand side, you don't have any number. You can assume it to be 1, right? So the integration on the right side, integration of 1 with respect to t, that's just t. And you have a constant here, t plus c. Now, what about the left-hand side? How do we integrate the left-hand side? Which rule can work here? 1 over at minus kv?
ln rule?
ln rule again. Why? Because what's the derivative of the denominator? It's just minus k. We want minus k in the numerator somehow. Now, minus k is a constant, so we can bring minus k in the numerator. We could say in the numerator, we have minus k. And then to balance that, we have 1 over minus k outside. And now the fraction inside the integral, that is of log form. We have the numerator as the derivative of the denominator now. So what's the integration? Minus 1 over k outside remains as it is. Minus 1 over k into ln of at minus k times v. Okay, that's the solution to the differential equation. That's the general solution, but now we need to find the value of c. For that, do we have any information? Well, we highlighted this here. It said initially the tank is empty. If initially the tank is empty, what that means is when t equals 0, v is supposed to be equal to 0. Let's put those two things here, put those two values here. We say put t equal to 0 and v equal to 0 and see what that gives us. On the left side, we get minus 1 over k into ln of at minus k times v. That's going to become 0 equals 0 plus c. So the value of c therefore becomes minus 1 over k times ln of at. So the solution therefore becomes minus 1 over k into ln of at minus k times v. That equals t minus 1 over k into ln of at. That is what the solution of the differential equation turns out to be. Now, if they had not specified any particular form, we could just make it a single log and that will be it. But now in this case, they basically want us to make v the subject. V needs to be made the subject here. Now, how do you make v the subject? And you see there's no log term here as well. How do you go from this form to the form that's given in the question? You need to make v the subject. Now, for that, remember, the first thing you have to do is you have to write this whole thing as a single log term. As in the multiple log terms that you have to convert them to a single log term. How can you do that? You can bring this term to the left and see what that gives you. Bring that to the left side. That's going to give you 1 over k into ln of at minus 1 over k into ln of at minus k times v. And on the other side, you just have t. Okay. What do we do now? We need to apply division law to make it a single log, but we can't do that unless the number outside is 1. Now, we could either take these to power, but in this case, since both of these numbers are the same, it's going to make things simpler if we just take 1 over k common outside. So that leaves us with 1 over k into ln of 80 minus ln of 80 minus k times b. That equals t. And now this part can be written as ln of 80 divided by 80 minus k times b. We could take this k to the other side, multiply that with t. This is what we end up getting. Okay, 80 over 80 minus kv, that equals, ln of that equals k times t. What do we do now? To make v the subject, we can take e to the other side, make it the base of kt in indices form, so that we get 80 over 80 minus k times v, that equals e raised to power kt. Now we need to make v the subject, multiply this on the right side, bring e raised to power kt down here, and that's going to leave you with 80 over e raised to power kt equals 80 minus k times v. You could bring v to the left, take this to the right. What does that give you? Kv equals 80 minus 80 over e raised to power kt. Now if you just divide k on the other side. But now, before you do that, let's just have a look at what the final result needs to be. The final result needs to be 1 over k into 80 minus 80 e raised to power minus kt. This is the final result that we want. So yeah, so it looks like we're almost there. We can just divide k on the other side, so it becomes 1 over k. And then this thing, what's this? It's 80 minus 80. But now you have e raised to power kt in the denominator. If you bring that to the numerator, the power is going to become negative. So it becomes e raised to power minus k times t. And that is what you wanted to do there. You have v as the subject, and you've proved this thing that they wanted you to do. Is that okay? First part, any problem with this? Okay, let's look at the next part now. So we've got v in terms of t. Now the next part says, it's observed that v equals 500 when t equals 15, so that k satisfies this equation. Now they've already given this here, and they want you to do iteration. Now this is an iteration problem. We haven't done that yet, but those of you who remember that, all you have to do is use this iterative formula with 0.1. So just do this on your calculator. The initial value is going to be 0.1. Put this function on your calculator. Save this in the answer button. Just keep pressing the equal button again and again, and you'll get the result. But we'll discuss this after the ease break when we do iteration. The second part is iteration, and it's a simple application of that. So that's not a problem. We will discuss that concept after eat. Let's look at the third part for now. Determine how much liquid there is in the tank 20 minutes after the liquid starts flowing, and state what happens to the volume of liquid in the tank after a long time. Okay, let's look at the third part because that is related to differential equations. Now, for that, we would need the value of k from the second part. I'm not going to tell you what the value of k is from the second part. What's the value of k from the second part? Okay, so this was question number 27 from the worksheet. From the second part, when you use the iterative formula, you would get the value of k to be 0.14. Okay, so from the second part, the value of k would turn out to be 0.14. You'll just use iteration for that. Now the third part, you've got this differential equation. And now you know the value of K. The value of K is 0.14. Now they basically are asking you, determine how much liquid there is in the tank 20 minutes after the liquid started flowing. So when the value of T is 20, what's the value of the volume? That's pretty straightforward. You just have to input that value here. This is also supposed to be minus 0.14 times T. Just input that value of T. You'd say put T equals 20 here and see what that gives you. 1 over 0.14 into 80 minus 80 e raised to the power minus 0.14 times 20. What do you get for that? Put this whole thing in your calculator and see what that gives you.
536.6768.
536.68. So you can say 536.7, or to three significant figures, 537. That's the value of V when T equals 20. But then it says, state what happens to the volume of liquid in the tank after a long time. Again, that means the same thing. After a long time means as T goes to infinity. Okay, long time means very long time, right? When T goes to infinity, what happens to the volume? Now, let's think about that. What happens to the volume as T becomes very large? Now, this is what the function looks like. As T becomes very large, what happens to this thing? This goes to 0, right? As T goes to infinity, what happens to e raised to the power minus 0.14 T? This goes to 0. So this whole thing becomes 0. So we're just left with V equals 1 over 0.14 into 80. And that's going to give us a result. What do you get from this? 80 over 0.14?
71.4.
5?
71.4.
571. This is the value of volume that we get for this. Okay. Or you could do that other method as well. You could say just input a large value of T here. You could say V equals 1 over 0.14 into 80 minus 80 e raised to the power minus 0.14 and replace T with a large value, maybe 999, and see what that gives you. That will give you something very close to this as well, 571. And that's your final result. Okay. Any other questions from the words? Yes, Fazan.
So e raised to power minus 0.14 T was equal to 0 because the power was negative?
Yeah, so e raised to power minus 0.14 T is basically 1 over e raised to power 0.14 T. Right? So in the denominator, you have a very large number, so that becomes 0.
Okay, sir.
Okay. Any problem with this? Any other questions? One last question that we can do today. Let me know. When we come back from the Eid break, we will be doing iteration. Okay, that's one last topic that we're left with, and then it'll be it as far as P3 syllabus is concerned. I also have that past paper session starting, by the way, from 13th of April. Those of you who are part of the crash course, you can register at any time and you'll get that discount. For others, that time has ended. But for those of you who are part of the crash course, you can register anytime. It starts from 13th of April. The registration link, I think I've posted that on the WhatsApp group earlier as well. I'll do that some point today, I think, again. You can have a look at the details there as well. Let's have a look at question number 17, one last question for today. And then we end. In fact, there's a small thing that I want to talk about after this question as well. I think it was from another question number 3. Just the last part of that, 1 mark. We will discuss that after this and then we end. Okay. All right. So it says the number of birds of a certain species in a forested region is recorded over several years. At time t years, so one variable is t years. The number of birds is n. So we have 2 variables. One is time and the other is number of birds. That's n. Where n is treated as a continuous variable. So n, number of birds, practically it has to be an integer, right? But for the purposes of modeling this as a differential equation, we treat that as a continuous variable. That means the value of n here could be in decimals as well. The variation in the number of birds is modeled by this. So they've given you this differential equation. It's given that n equals 300 when t equals 0. Find an expression for n in terms of t, and that's a 9-mark question. So that's a lot of marks. So maybe the integration is going to be difficult here. Let's try this. dn over dt, that equals n into 1800 minus n divided by 3600. We need to solve this differential equation. How do you solve this differential equation? You separate the variables first of all. You take dt to the right side and bring these n terms to the left. So it becomes 1 over n into 1800 minus n dn. On the right side, you have 1 over 3600 into dt. Now it's your choice if you want to keep 3600 on the right side or take it to the left side and multiply there. You could do it either way. It doesn't make any difference. But now that we have separated the variables, we can now just integrate both sides. What's the integral of the left side? How do you integrate the left side? What rule can we use here? Any idea?
Partial fractions.
You have factors in the denominator. So that should remind you of partial fractions. You can break these 2 fractions down into 2 parts because the other rules do not work. ln rule doesn't work. Tan inverse rule does not work. It's not that form. You can't break the numerator. It's not an improper fraction. So none of those other rules for fractions work here. But you have factors in the denominator. You can use partial fractions for that. Let's find the partial fraction for that. So let's just stop the integration process here for now and do partial fractions first. 1 over n into 1800 minus n. You've got 2 linear factors. That's going to become a over n plus b over 1800 minus n. Okay, now multiply this thing on the right side, and that gives you 1 identical to a into 1800 minus n plus b into n. Now input some values of n here. You could input n equal to 0 because that will eliminate this term. What does that give you? 1 equal to a into 1800 minus 0. So that's a equal to 1 over 1800. And then you input another value of n. You could input n equal to 1800 to get rid of this term. And that gives you 1 equal to 0 plus 1800 times b. So what's the value of b? The value of b is 1 over 1800. A and b both turn out to be 1800. So now this can be written as integral of a over n. That means 1 over 1800 times n plus b over n. That means 1 over 1800 minus n into another 1800, in fact. It's going to be 1800 multiplied by 1800 minus n, like this. This is what this left-hand side becomes. You can split it into two parts. You can write this term separately, this separately. You can say integral of this and integral of this on the left side. On the right side, you just have this thing, 1 over 3600 integral of that with respect to t. Okay, this is what we've got. Now, in fact, if you think about it, it will make things simpler if you multiply 3600 on the left side, because it'll make this fraction simpler and make this fraction simpler. You could do that if you wanted, or you could leave it like this. That's your choice. How do you integrate these terms now? I can write 1 over 1800 outside. That leaves me with 1 over n inside. Now I can apply the log rule on this. Similarly here as well, I can write 1 over 1800 outside. That leaves me with 1 over 1800 minus n inside. Now, what is the derivative of the denominator? What's the derivative of 1800 minus n? It's minus 1. You want minus 1 in the numerator. You can have minus here. And to balance that, you can have minus outside as well. On the right side, you've got this thing. What's the integration of 1 over 3600 with respect to t? It's going to be 1 over 3600 multiplied by t. On the left side, you have 1 over 1800 into ln of n minus 1 over 1800 into ln of 1800 minus n. And on the right side, you've got 1 over 3600 t. And now that you're done with the integration on both sides, you can have a plus c here as well. This is what this turns out to be. Any problems with this? Any questions, anyone? Until this point? No? Now let's simplify this a bit. I could multiply 3600 on the left side, but remember there's a c here as well. So when you multiply the whole equation by 3600, you end up with 2 ln n minus 2 ln of 1800 minus n. On the right side, you have t plus 1800 times c. Now, if you wanted, you could write it as just another constant. So let's say this was c1. 1800 into c1, that's just another constant. So I could write it like this, t plus c. So let's say this is also a constant. Just to simplify things, just to not write 1800 times that, you get this. Now the left-hand side, what you want to do now is you want to make n the subject. So you want to convert it to a single log first of all. How can you do that? You can take 2 common outside. That leaves you with ln n minus ln of 1800 minus n inside. Apply division rule on this. That becomes 2 into ln of n over 1800 minus n. On the other side, you've got t plus c. Okay. Any issues until this point? In fact, we had to find the value of c as well. I messed with that. So now we can find the value of c. It says n equals 300 when t equals 0. Let's use that to find the value of c now. Put n equals 300 and t equal to 0. See what that gives us. 2 ln of 300 over 1800 minus 300 equals 0 plus c. So c turns out to be 2 ln of 300 over 1500, which is 1 over 5. That's the value of c. Okay. And now we'd have to apply the log rule again. We could actually find the value of c first and then do this. That will make things maybe a bit more efficient. We could find c at this point before converting it to a single log. Now that we've done it, let's just continue like this. Now we have 2ln of n over 1800 minus n. That equals t plus 2ln of 1 over 5. Now you need to convert this ln to a single form as well, to a single ln as well. You've got 2 ln terms here. You need to convert them to a single ln term. Let's bring that to the left side. That gives you 2 ln into n over 1800 minus n minus 2 ln of 1 over 5. That equals t. Take 2 common again. That leaves you with ln of n over 1800 minus n minus ln of 1 over 5. Apply the division rule on this again. 2 remains outside, and we have 2 into ln, or we could take 2 to the other side as well. So that on the other side, we've got t over 2. ln of this thing divided by 1 over 5. So you have n over 1800 minus n divided by 1 over 5. What does that become? That becomes multiplied by 5. So we could write this 5 in the numerator like this. You've got 5n over 1800 minus n. That equals t over 2. Any problem until this point? Any confusion? Does anyone have any questions until this point?
No, sir.
No? Okay, so what do we do at this point? The base of ln is e. E goes to the other side. It becomes the base of t over 2. So you have 5n over 1800 minus n. That equals e raised to the power t over 2. And now you need to make n the subject. Multiply this on the other side. That will give you 5n equals 1800 e raised to the power t over 2 minus n e raised to the power t over 2. Bring the n term to the left side. 5n plus n e raised to the power t over 2. On the right side, you've got 1800 e raised to the power t over 2. Now take n common. That leaves you with 5 plus e raised to the power t over 2 equals 1800 e raised to the power t over 2. And you finally get n equals 1800 e raised to the power t over 2 divided by 5 plus e raised to the power t over 2. That is n in terms of t. That is the final result that we end up getting from this. Is that okay? Now it became slightly longer than what it should have been. We just did a couple of extra steps here. So if we found C right at this point, we could save 2-3 steps in this working, because we had to apply the log rule twice here. If we found the value of C first, then we could just get to this point directly. Okay, we could skip a couple of steps at least in the working, but that's what you get at the end. N equals 1800 into e raised to power 2 over t over 2 divided by 5 plus e raised to power t over 2. Okay, now let's look at the next part. Part 3 of this. Sorry, part 2 of this. Now in part 2, it says, according to the model, how many words will there be after a long time? So when t goes to infinity, what's the value of n? That is what they're looking for. So now what happens when t goes to infinity in this case? Now this is interesting. In fact, I wanted to talk about something similar next as well. That's what I was referring to. I think it might just be covered here. I'll give you another example of this, but you have n equals 1800 e raised to power t over 2 divided by 5 plus e raised to power t over 2. What happens if t becomes very large? One possibility is you put this in a calculator, and we'll discuss that. But how do you think of it directly like this? So as t becomes very large, what do you think this is going to be? Without using calculator, think of it. What do you think this should be? Yes, Faizan?
1.
1? Why 1?
Because, sir, the numerator becomes infinity and the denominator also becomes infinity.
And you're saying infinity over infinity is 1, right?
Yes.
But infinity is not a number. Infinity is just something that we use for an extremely large number. But the thing is, we've got something, we can compare infinities in a way as well. You have some infinities that are larger than other infinities, okay? Now, that might confuse you a bit. I'll explain that to you in a moment. Let's put this on your calculator and see what your calculator gives you. If you were to try this using a calculator, remember the method that we discussed for that? Put a large value of t. So you could try, for instance, n equal to 1800 e raised to power 999 over 2 divided by 5 plus e raised to power 999 over 2. Does that give you a result? Or is it an error?
Error, sir.
Error? Okay, so try 99 then. So try 99. 99 over 2, 99 over 2. That should give you a result. It gives you 1800. So it's not 1, it's 1800. Now, how does that make sense? Because when t becomes very large, you can see e raised to power t over 2, that should go towards infinity. 1800 into infinity, that's also infinity. In the denominator as well, you have 5 plus infinity, that's also infinity. But think about this. When you're talking about extremely large numbers, so think about 1 million, for instance, okay? So let's say you have 1800 into 1 million divided by 5 plus 1 million. Now, does it make any difference when you add 5 to 1 million? Does that make much difference? Think of a larger number instead of this. In fact, let me actually use this. Let's say you have even larger number, 10 raised to power 10, let's say. In the denominator, you have 10 raised to power 10 plus 5. Now, does this 5 have much significance? Adding 5 to a very large number, it does not change the number much, right? We're just adding 5 to 1 billion, 1 trillion. Plus 5 would not make much difference. However, how about 1800 multiplied by 10 raised to power 10? Does that make much difference? That does make a lot of difference. That the number was extremely large already, but then you're multiplying this by 1800. Adding or subtracting does not make much difference, but multiplying does make a lot of difference. So what happens is, as t goes towards infinity, you get something like this. In the numerator, you have 1800 e raised to power infinity. In the denominator, you have 5 plus e raised to power infinity. Now, 5 plus e raised to power infinity, that's almost the same as e raised to power infinity, because adding 5 is not really going to make much difference. But multiplying does make a lot of difference. Now, this gets cancelled because the infinity in the numerator is 1800 times approximately times the infinity in the denominator, and you end up getting 1800 for that. So when you have something multiplying in the numerator or denominator, you can't just ignore that and say that, okay, you have infinity in the numerator, infinity in the denominator, so they should mean the same thing. No, you would have to split it like this. Is that okay? Or you could just use your calculator, and at this level, that's going to be easier. Put a large value in your calculator. Sometimes it will give you an error because it can't handle that larger value. In that case, make that value slightly smaller, and that will be it. Okay. All right, now let me give you another similar example. I think this is in question number 3. Yeah. So in question number 3 in the worksheet, you have something very similar. Let me just end with this now. I'm not going to do the first 2 parts. I'm just going to talk about the last part. In the first part, it says using partial fractions, find this integral. In the second part, you have to solve this differential equation. You can do that. Now, in the last part, it says, state what happens to the value of y if x becomes very large and positive. Now, in the second part, when you have y in terms of x, it actually comes out to be something like this. Y equals 4e raised to the power 4x divided by 3 plus e raised to the power 4x. So once you're done with the second part, you end up getting y in terms of x like this. Now it says, state what happens to the value of y if x becomes very large and positive. What do you think? Again, without a calculator, can you tell me what the value should be in this case?
4.
It should be 4, right? Because when x becomes very large, this 3 does not make any difference. You adding 3 to a very large value. So you can say as x goes towards infinity, you can say y is approximately equal to 4e raised to the power infinity divided by e raised to the power infinity. This 3 does not make much difference anymore, right? Adding 3 to a very large value, it does not change the number much. E raised to the power infinity, e raised to the power infinity, they get cancelled, and you're left with y equal to 4. So y approaches 4 in this case. Again, the other possibility would be just to input this in your calculator. You'll write something like this in your calculator. You'll say y equals 4 e raised to the power 4 multiplied by 99, let's say, in case your calculator can handle that. 3 plus e raised to the power 4 into 99. And that should also give you 4 as the result. Make sense? Another way to think about this could be, now that's harder to think of, but it makes it easier to just understand the function logically. You could write this function like this as well. You could take this e raised to the power 4x to the denominator and write it like this. Y equals 4 over e raised to the power minus 4x into 3 plus e raised to the power 4x. Right? So you take e raised to the power 4x to the denominator like this. It becomes e raised to the power minus 4x when it goes to the denominator. Now, what does this become? 4 over 3 e raised to the power minus 4x plus e raised to the power minus 4x into e raised to the power 4x. What's that? It's going to be e raised to the power 0, which is 1. So you have y equals 4 over 3 e raised to the power minus 4x plus 1. And now you can think of it like this. You can say as x goes to infinity, what happens to this thing? 3 e raised to the power minus 4x, this goes to 0. Right? E raised to the power minus 4x, this goes to 0 as x goes towards infinity. And you're just left with y equal to 4 over 0 plus 1, which is 4. This could be another way to think about this. But again, if this is just for your own understanding, in the exam, I think the easiest way of doing this would be on the calculator. Okay? But if you're interested, this is also another way to think about this. Okay. Makes sense to everyone? Any confusions? Okay, that's great. So those of you on YouTube, just a reminder, I have this past paper session starting from 13th of April. I'll be covering paper 1, paper 3, M1, and S1 in these past paper sessions. We'll be doing a lot of papers from the last 4 or 5 years, from 2020 to 2024, March. You can find the details of the course in the registration link that you can see in the description below, and also in the live chat on the right side. All the details of the course are mentioned there. I've responded to a number of frequently asked questions in my last post on Instagram and also on YouTube. You can have a look at that, where a number of questions are answered. For example, how many years of past papers we'll be covering, how many sessions we're going to have for each session, for each paper, how many will we be doing complete papers or just difficult questions? All of those questions are answered there. You can have a look at that post as well. And if you're interested, you can see the registration link here. You can sign up there. Okay, so we start this Saturday, 13th of April. We'll have an introductory class on 13th, in which we'll discuss some important points while we attempt the papers. And then from 15th, we start our first paper then, inshallah. All right. No, unfortunately, we're not doing S2 in that course. I don't teach S2 currently. Maybe in the next year or two, I will start that as well. But unfortunately, for now, I've not been getting the time to do that. So it's only P1, P3, M1, and S1. Okay. All right. So that's it for today. I'll see you again in another session. And I'll hopefully see some of you there in that past paper session as well. That's it for today. Allah Hafiz.
Allah Hafiz.
Allah Hafiz. Okay.